Hey guys, please be quiet. Okay. So this is coming from your textbook. Example 1. It states marriage. I'm just going to write stuff up on the screen. You don't have to copy all of this down in your notes. Just write down, this is example 1 from the textbook. And that should give you at least an idea. So, so it starts off saying historically, 70% of all U.S. adults have married. Okay, so meaning get married at some point in their life. Okay, a sociologist believes this marriage rate has declined. Okay, he will take a random sample. So if you have the second edition, I don't know what it is in the first edition, but it's page 364 in your textbook. You'll take a random sample to test this hypothesis. Okay.
What is the word after marriage?
Marriage rates. A sociologist. Rate. This marriage rate has declined. He will take a random sample to test this. Okay. So in this case, what would our hypotheses be? Okay, we have a null hypothesis and an alternative hypothesis. So we want to take our data and test to see what it says. 70% of all adults have married historically, and a sociologist today believes this marriage rate has declined. So we want to know, has the marriage rate declined? Okay. So our null hypothesis is going to be that the marriage rate has not declined, and the alternative will be that the marriage rate has declined. Okay. Now how do we know which one is the null and which one's the alternative? Okay. So based on this setup, one is going to be the marriage rate has not declined, and the alternative is that the marriage rate has declined. Okay. So how can we express that the marriage rate has not declined?
Because it's equal to.
Yeah, we would say if we select someone at random and we ask, are you married or not, the probability that this person is married should be what? 0.7. Okay, if the marriage rate has not declined, it says 70%, so we are expecting P to equal 0.7. That's the null hypothesis, and it's always going to have an equal sign. Okay? How would we express that the marriage rate has declined? P is less than 0.7.
Would you be expressing something different if you're not?
Yeah, so if the sociologists believe that the marriage rate has, if it said something like changed, okay? So if we use the word changed here, then in that case, the alternative would be the marriage rate has changed, and what would P be? P not equal to 0.7, okay? So if you have the exact same thing except you replace the word declined with changed, then your alternative will say this, and then you'd have P not equal to 0.7. Is that okay? Let's talk about, let's look at example 2. Okay, and so it says they want to, a retail business online wants to decide whether to spend more money on advertisements. Okay, so their past click-through rate is 0.15. Okay, so that's when the advertisement is shown, how many people click the ad. Okay, and the advertiser claims that upgrading to premium ads will increase their click-through rate. Okay? So, you know, they do a test trial. They get a trial period or whatever, test trial, to see if this is true. Okay, with premium ads, the click-through rate was 17%. Okay. Does this mean the click-through rate of premium ads is higher? Okay. So in this case, we want to, again, write hypotheses. So we have the null hypothesis, and we have the alternative hypothesis. What is the null hypothesis?
That the click-through rate remained at 70% or did not change? Or 0.15?
It didn't go up.
It's not higher.
Okay. So let's state it in words first, and then we'll do the P's. Okay. So click-through rate is not higher, right? Click-through rate did not change. And the alternative is that what?
It did.
Click-through rate
Did change.
is higher for premium ads. Okay, or the click-through rate is the same for premium ads, and the click-through rate is higher for premium ads. Okay, so how do we express that the click-through rate did not change in terms of P? P equals what? 0.15 or 0.17?
17.
No, it's 15.
0.15. 0.15. Okay, because we are looking at towards our historical data. P equals 0.15. And what should the alternative be?
It's more than
P is greater than, what number do I put here?
0.15.
0.15, okay? So remember, the alternative is identical to the null, except the only thing that changes is the equal sign is now something else. Great, and in this case, greater than. Okay? So what is 17%? What role does this play in our problem? 17%, this is our sample proportion. Is our data, our sample proportion. Okay, we have a question.
Is it okay for the null to have a less than or equal to sign? I say that it dropped below for some reason.
So the null hypothesis will always be equals. Okay.
I was just thinking in the case like that, say the premium ads change it to somehow 13%. Would it still be the null hypothesis then?
So the null hypothesis always has an equal sign, and if the premium ads drop down to 13%, then that would not be a compelling argument to upgrade to premium ads. Okay, you don't even have to do any statistical analysis here. You would say, well, when I did the premium ad trial, my click-through rates actually went down, so I'm not going to upgrade. Okay, the question here is, okay, so I upgraded to premium ads and it went up to 17%. Does this actually mean the click-through rate changed, or could this just be a fluctuation in, day-to-day fluctuation in ad traffic, right? Because I'm not going to get 15% every single day, right? It might go up or it might go down. And so the question is this 17%, is that significantly different from 15? Or could it just be we just happen to get lucky during the ad trial? That's what we're asking, okay? Does that make sense? Okay. All right. So far, so good with everyone? Everyone feels okay with making hypotheses? Okay. And then we talked about, so again, I'm leaving out the middle section of calculating the p-value. It's an important section, but the conclusions we make depend on our p-values, right? So we calculate a p-value and then we make a conclusion, okay? So we then calculate p-values and make conclusions. And I said something along the lines of, if the p-value is small, does this provide evidence against the null, or does it not provide evidence against the null, or what does a small p-value mean? So think about this, right? When it was very unlikely that the person could get 800 wins out of 1,000, what did we conclude? We concluded that the null hypothesis was true, or that the null hypothesis was wrong? That the null hypothesis was wrong, right? So so in that situation, if the p-value is small, we say we have evidence to reject the null hypothesis, okay? And so we write something like the p-value is less than alpha, okay? Alpha is an arbitrary number we select, okay? It looks kind of like the letter A. Alpha, I don't know. This is an alpha, okay? So alpha is often 0.05, but could also be 0.10 0.02, 0.01, okay? Or really any value. But these are common choices for alpha, okay? So generally this is our criteria. If the p-value is less than alpha, we consider the p-value to be small, whatever we choose alpha to be. So p-value less than alpha, reject the null hypothesis. And on the other hand, if the p-value is large, or in other words, that the p-value is greater than alpha, we do not reject the null hypothesis. And we'd say we do not have evidence that the null hypothesis is wrong. Okay? It doesn't prove but this does not prove that the null hypothesis is true. Okay? So let me give you guys a chance to write that down. Did you guys get that? So let's revisit our internet ad example. Okay, and so our null hypothesis was that click-through rate is 0.15, and the alternative is that the click-through rate is greater than 0.15. Okay, so click rate did not change with premium ads, and the alternative is that the click-through rate increased with premium ads. Okay, so let's say we have alpha equal to 0.005, okay? And we do the math, and we get p-value equal to 0.09. What do we conclude? Okay. Yeah, what do we do? I'm just making it up, okay? 0.09. I'm just saying, okay, so we choose our alpha, okay? So we choose. So the p-value, so we're going to do the math and we calculate the p-value. And I haven't explained how we calculate the p-value. It's coming, all right? What I want to know is what conclusion are we supposed to make?
You cannot reject.
Yes, so our conclusion is do not reject the null hypothesis. Now what does that mean on a practical level? Okay, the p-value is bigger than alpha, that's why we do not reject the null hypothesis. Everybody can see that? Okay, so what does it mean not to reject the null hypothesis in this scenario? Should we upgrade to premium ads or should we not upgrade to premium ads?
No.
What do we say? So what this is saying is that, okay, you know, right on my data, our p hat when we had the premium ads, our click-through rate was 17%. And what this says is that, you know what, even if the click-through rate doesn't change with premium, you could get 17% click-through rate just from random chance 9% of the time. Okay, so this means we are not convinced that premium ads are better. Premium ads are better. Okay, whether you decide to upgrade or not, maybe that's a tougher call, but this is not convincing evidence that premium ads are better. Okay, does it prove that premium ads are equally, or that the current ads are just as good as premium? No, it doesn't prove that. Okay, it just means based on our test period, we're not convinced that it's better. They could actually be better, but based on the data we collected during our test trial, it's not convincing to us. Okay. On the other hand, let's say we choose alpha to be 0.05, and this time the p-value ends up being 0.01. Now what? So our conclusion is to reject the null hypothesis, and then what would we say? We would say we have evidence that leads us to believe premium ads have a higher click-through rate. Okay. Do these conclusions make sense? Okay, because the p-value, what is the p-value again? It's the probability of observing our data or something more unusual if we assume the null hypothesis is true. Okay, so what this says is that if we assume that the premium ads were the same as the current ads, it would be incredibly unlikely for us to just suddenly see this magical bump in our click-through rate, right? So if my click-through rate jumped up to 17%, and if we're just assuming that the premium ads are the same as the current ads, it would be very unusual for us to just see this magical bump. Okay? It could be that we just happen to see this really strange week where this happened, but the more likely explanation would be that the premium ads actually do make a difference, and that's why we saw the 17% in click-through rate. Is that okay? All right. So we have, so let me do how to get our p-value, okay? So in our null hypothesis, you're going to have p equal to some number, okay? Some number p0, okay? Now, we have all these p's here, okay? Just see this as some number in the null hypothesis. So, for example, it could be the null hypothesis is that p is equal to 0.15, okay? Now, notice when I write the null hypothesis, I write null hypothesis colon p equal to 0.15. Do not write the null hypothesis is equal to 0.15. This is wrong, okay? Do not do that. The null hypothesis is never equal to some number. The null hypothesis is a statement about p equaling some number, okay? Because it's in language form, we always say, that the click-through rate has not changed, okay? It's not null hypothesis is 15 or 0.15. It's the null hypothesis is that the click-through rate remains 0.15, okay? So anyway, you have your null hypothesis equal to this, okay? So there's a few steps. One of them is to calculate your standard error. Standard error is going to be, so your standard error is equal to the value in your null hypothesis, P0 times 1 minus P0 over n. So in this example, our standard error would be the square root of 0.15 times 1 minus 0.15 divided by n, whatever n is given in our data. Okay. Then your test statistic is very much like a z-score. And so in our case, we would say z is equal, and we would write p hat minus p0 divided by the standard error. Okay. So if in our data we have p hat equal to 17%, my z would be 0.17 minus 0.15 divided by the standard error, whatever number we get up here. Okay, and then your p-value is look up the test statistic in your z-table. Okay, so let me just label these. These are the sub-steps, okay? So the p-values, you look up your test statistic in the z-table, okay? And if, so wherever your test statistic is, if the HA has less than, p-value is area to the left. So if your test statistic is over here, you're going to take the area to the left. If the alternative has greater than, p-value is the area to the right. How do we get the area to the right in our z-table? Yeah, you do 1 minus whatever it is, okay? Okay. And if the p-value, if the alternative has a not equal sign, we call this a two-sided test. The p-value is equal to 2 times the tail area, okay? So whatever number is, whatever number you get, find the side that doesn't have the hill, okay? So that might, if you get a negative value, it's going to be the area to the left. If you get a positive value, it's going to be the area to the right. And whatever it is, you multiply it by 2, okay? Okay, so that's how you get your p-value. You find your standard error, you find your test statistic, you look up your test statistic in the z-table. Question?
I don't understand this. If it's not equal to, how do you?
We'll do an example, okay? All right, let's try this. Okay, so let's say okay, an old survey found that, I don't know, 30% of people 30% of people like, I don't know, what do they like? What do 30% of people like? They like aliens. Okay, I guess we love aliens today. All right, nobody 30% of people don't like. All right, we'll say alien movies. All right. Huh? So 30% of people like alien movies. Okay, so a survey conducted this year asked, we will say 840 random people, okay, and asked if they like alien movies. And we will say 302 said yes. Okay? Does this survey provide evidence that the proportion of alien movie fans has changed? Or we'll say, okay, yeah, we'll say has changed. All right, so the most important step. What is our hypotheses? What are our hypotheses? Null and alternative. Okay, so one is that it hasn't changed, and the other one is that it has changed. Okay, we're talking about proportion of alien movie fans has not changed versus that it has changed. So how would I express this with a symbol? I have P equal to 0.3 versus P not equal to 0.3. Okay? What is my data? What is my sample size? N is 840. What is my P hat? I'm going to have to do what? 302 divided by 840. So I get P hat equal to, so 302 divided by 840, 0.3595, okay? So that's my P hat, okay? So now we want to get our p-value so we can make a conclusion, right? So we're going to find the p-value. So what is the first step we do in finding our p-value? I listed off the 3 sub-steps, right? Find the standard error, right? So what is the standard error? It's going to be square root of p0 times 1 minus p0 over n. So I get the square root of, what numbers do I plug in there? 0.3 times 1 minus 0.3 divided by 840, right? I'm using 0.3 from my null hypothesis and not 0.3595 from my p hat. Okay, so I punch this into my calculator. And I get 0.0158. Okay. Is this okay with everyone? What is the next step I do? test statistic. Okay, so my test statistic is z is equal to p hat minus p0 divided by the standard error. Okay, you should have this in your notes. So what do I put in here? What is my p hat? 0.3595 minus, what's p0? 0.3 divided by, what's my standard error? 0.0158. Okay, so I'm going to punch that into my calculator. 0.3595 minus 0.3, close parentheses, and I could type in 0.0158, but I already have it in my calculator, so I'm just going to say divide by the answer. Okay, and I get a z-score of 3.76. Does that seem big or small? Pretty big, right? Okay. I go to my z-table, and what do I have for 3.76? What am I doing here? So step 3 is look up in z-table, right? Okay, so I go and I'm looking for 3.76, and it doesn't even show up. Okay, I can look up 3.5 and 4.0. Okay, so if let's just say we got 3.49. We didn't, but we got 3.76. Okay, so it means I'm going to have something even closer to 1 than 0.9998. Okay, so let's pretend. Okay, let's pretend z is equal to 3.49. Okay, because I want to just show what to do. Okay, so if I look up the z 3.49, z equal to 3.49, this gives me an area to the left equal to 0.9998. Okay, so flip back in your notes and it says if the alternative has a not equal sign, what do I do? It says take your tail area and multiply it by 2, right? So if I got 3.49, I got 3.76, but just so we can actually do some math here, we're going to pretend I got 3.49. Is that okay with you guys? Okay. So if I look up 3.49, I get 0.9998. How much is in this tail over here?
0.0002.
Yeah, 1 minus 0.9998, so I get 0.0002. This is 1 minus 0.998, gives me 0.0002. But because my alternative has a not equal sign, I have a two-sided test, so I'm going to just double that and pretend I take this over here. So my p-value is equal to 2 times 0.0002, and I get a p-value of 0.0004. Is this okay?
Question.
Yes.
Explain real quick, how did you get the, on the left side, right?
Uh-huh.
I have the shaded area to the left. How did you get that?
Oh, that's just the picture to show you that you need to double it, okay? So whenever you have a not equal sign, you're going to take the area in the tail, okay? The tail is the side that doesn't have a hump, okay? So the tail area is always less than 1/2. If you double 0.9998, you're going to get like 1.99 something, okay? And that's wrong, right? Because your p-value is a probability. You can never have a probability bigger than 1. So if you're doubling this, you're doing something wrong. So you take 0.0002 and you double it, and you get 0.0004. This is my p-value. What is the conclusion I make? Let's assume alpha is 0.05. What conclusion should I make? So is my p-value bigger or smaller than alpha? It's smaller than alpha, so we will reject what? The null hypothesis. And what does that mean?
You give us how much is alpha?
Yeah, if alpha is not specified, assume that it's 5%. Otherwise, you know, it might be specified in the problem and it'll say use alpha 0.01 or use a significance level. So that's another word for alpha, significance level. Okay, it'll say use this significance level or use alpha equal to 0.05. And if it's not specified, assume that alpha is 0.05. So my p-value is smaller than alpha. And what does that mean? It means we reject the null hypothesis. And so what is our answer to this question? Does this survey provide evidence that the proportion of alien movie fans has changed?
No.
And the answer is yes. Okay? Because before it was 30%, and now we have pretty significant evidence that it's not 30% anymore. Okay? We have evidence that the proportion is not 0.3 anymore. Is this okay? All right. I wish we had more time, but we don't. I would like to do more examples, but you will face examples in your homework, and I suggest you study those. Study this example also. I'll post a practice quiz this week that will kind of break things down, but we'll do it. Yes. Yes, you can use a chart. Okay. So that was hypothesis. Question. Like I said, everything is it is a lot of work. Okay. I think I'm doing you guys a favor by posting these practice quizzes. So, you know, I'm trying to get stuff, but it is a lot of work. So please, you know, be sympathetic to that. Okay. So here's we are going to cover two types of hypothesis tests. We also have hypothesis tests when you have two samples. With two samples. Okay. And so in this case, we're going to ask some question comparing two groups, okay? We ask if the proportion of whatever is the same for two different groups. So for example, you know, is the proportion of men who like pizza the same as the proportion of women who like pizza? What do you think? Yes? No? I don't know. It's hard to say, right? You certainly have... Well, I don't know. Okay. Yeah, I don't know. Is the proportion of men who like pizza the same as the proportion of women who like pizza? Just curious, what kind of data are we looking at here? Data being, are we looking at numeric data, categorical data? What are we looking at? Categorical data, right? Because we're asking, are you a man or are you a woman? Do you like pizza or not? Those are all categorical questions, right? So in essence, we're asking, you know, are these two categorical variables independent or not? Okay. So what we want to know is, let's say we take a survey. Okay, we survey, let's say 200 men and 250 women. How many of the men, how many do you think like pizza out of 200 men? Like pizza, 150, it's got to be like bigger than that, right? Okay, but maybe only 150 men like pizza. Okay, so 50 men out of the 200 don't like pizza. That's, I don't know. Okay. All right, and out of the 250 women, how many like pizza? 250. Okay, maybe I'm just gonna say 200. Okay, we'll just keep it simple. Who knows? All right. Random people we asked. So these are, okay. And we want to know, does the data provide evidence that the proportion of men and women who like pizza are, that the proportions of men and women who like pizza are different? That's what we want to know. Okay, so this is where things are different. To solve, huh? Does this question not make sense?
Left out.
Oh, men, and I left out the word women. That's an important word. Proportions of men and women who like pizza, are they different? Okay. So here we got 150 out of 200. That's like 75% of men like pizza. 200 out of 250, 80% of women like pizza, according to our random survey. Maybe it's not a reliable survey, but if this was our data, okay, maybe we went to, you know, some fantasy land. Okay, so our null hypothesis is that the proportions are the same. Okay, the proportions are the same. And so we write proportion of men who like pizza minus the proportion of women who like pizza is equal to, if they're the same, that difference should be equal to what?
0.
Should be equal to 0. So the proportion of men who like pizza minus the proportion of women who like pizza is equal to 0. And then the alternative is that the proportions are different. So we'd have proportion of men minus the proportion of women not equal to 0. Okay. Pay attention to this example also, because you might see something like this. All right. What do we get from our data? Our data we need for the men. What is the sample size for our men? So I'm going to just call sample size for men N1. What do we have?
200.
200. What is my p hat for men? So p hat 1.
0.75.
So 150 over 200 is 0.75. What about the women?
250.
N2 is 250. P hat 2 will be 200 divided by 250, 0.8. Okay. So what is the observed difference between observed difference is p hat 1 minus p hat 2, I get what? 0.75 minus 0.80, I get a difference of negative 0.05. I get a 5 percentage point difference between my two samples. So my two samples were not exactly the same. I'm seeing a 5 percentage point difference. And I want to know, does that mean that can I generalize this to the entire population and say for all men and for all women, or is the proportion that like pizza different? Or is 5% not a significant difference? That's what we're asking. Okay. So in this case, we're going to go through the same process. So we got the null hypotheses. We're going to find our p-values. Okay. The steps for the p-values are the same. The formulas are just different. Okay. The steps for finding the p-value are the same. You got to find your standard error, your test statistic. You look that up in the z-table. But the formulas are different. And this is, again, we are dealing with two samples. Okay? So let's talk about, so remember we have two samples. So the steps, find the standard error. Okay? So the standard error is going to be the square root. So this is where it changes, and it's just an ugly formula. There's nothing we can do about it. Okay, but again, the steps are still the same. So number 1 is find the standard error. Number 2 is find your test statistic. And that's going to be z is equal to p1 hat minus p2 hat divided by the standard error. 3 is look up test statistic in z-table to get p-value. Okay, so these steps are the same, it's just the formulas have changed. So just make sure that on your note card you say these are the formulas for 2 samples and you've got the formulas for 1 sample. Okay, because you don't want to mix these formulas up. The steps are the same and the thought process is the same, the formulas have changed. Are we okay? So let's do our example here, okay? So with our example, we're going to find p hat and plug that in to get our standard error, okay? So p hat is, we're going to take x1. This is how many men like pizza. How many men said they like pizza? 150. How many women said they liked pizza? 200. Okay, what was N1? 200 men. How many women did we survey? 250. So my p hat is equal to 350. I add 150 plus 200 and I get 350 divided by 200 plus 250, 450. Okay? Make sure you add up the top and add up the bottom. Don't punch into your calculator 150 over 200 plus 200 over 250. Make sure you add up the top and you add up the bottom. Okay? And so you'll get p hat is equal to 350 divided by 450, and you get 0.7777. Or I'm going to just round out 7778. Is this okay? Question?
How do you know if you're using 4 digits or only 2 digits?
That I'd say keep more decimals. More decimals is better. You don't. I'd say 4 decimals is good. Okay. All right. We're gonna plug this in to get our standard error. We're going to do 0.7778 times 1 minus 0.7778. because we're plugging in p hats, times 1 over n1. What is n1? 200. And what's n2? 250. Okay? And so now we punch this into our calculator. So I have 0.7777 already in my calculator, so I'm going to just do that because it's going to do answer times, and I'm going to do 1 minus the answer times parentheses 1 divided by 200 plus 1 divided by 250. And I'm going to close off the parentheses. I'm going to take the square root of that number. And I get 0.0394. .03944. Okay, so that's our standard error. So it's kind of a lot of work to find the standard error for this problem. Okay, but we can do it. We're going to find the test statistic z. Okay, so z is equal to p hat 1, 0.75, minus p hat 2, 0.80, divided by the standard error, 0.03944. So I'm going to just do parentheses 0.75 minus 0.80 divided by, I'm going to hit the answer key and hit equals. And I get negative 1.267. So I'm going to just round off to negative 1.27. Okay? So whenever you get a z-score, that's when you can round off to 2 decimal places. So round off to 2 decimal places for a z-score. Okay? So the p hat, I would say keep the p hat to 4 decimals.
No, but where do we get the p hat 2?
P hat 2, this is the sample proportion from the men who like pizza minus the proportion of women who like pizza. Because we have 2 samples, right? Okay, so we get a z-score of negative 1.27. I'm going to look this up in the z table and find the area in my tail. Okay, so I look up z equal to negative 1.27, and I get something like 10%. Negative 1.27 gives me 0.1020. Okay. What was my alternative hypothesis? My alternative hypothesis, what symbol did it have in it? It was P1, P men minus P women, something 0. Greater than, less than, or not equal to?
Not equal to.
I had a not equal to sign. So what do I use for my p-value? I'm going to take this, and what do?
Times 2.
I'm going to times it by 2. Okay? So my p-value is equal to 2 times 0.1020. I get a p-value of 0.2040. This is my p-value. Okay. So after we're done with this example, it's going to be like 10 o'clock and we're going to be done. But I feel like I want to give you another example to solidify these concepts in your brain. Okay? So if you want, completely optional, you can take off at 10. You can take, really, you guys are grown-ups. You can take off whenever you want. But if you want to stay later and see another example and that I think will be helpful, I'll stay for, I'll do another example for you guys, okay? It's completely optional. I'll record it and I'll post it online also, okay? But this way you can ask questions and you can try it out yourself. Okay, so my p-value is 0.2040. Is everything okay so far with you guys? Kind of. Okay, so I'm going to go to the next slide. I upset the... oh, man, okay. Let me find this. Okay, my p-value is 0.2040. Next slide, are we okay?
No.
No. Yes.
Is it two, because it's a two-sided?
It's two-sided because of the not equal sign. This is the key here. Okay? Not equals means two-sided. So p-value is double the tail. That's the rule. I'm going to go to the next slide. Hold on. Okay, so my p-value ended up being 0.2040. Okay, let's assume alpha was 0.05. So what is the conclusion I make? My p-value is bigger or smaller than alpha? It's bigger than alpha. So what do? So we reject or do not reject? Don't say accept. We do not reject. What was my null hypothesis? The null hypothesis was that PM minus PW equals 0. What is that in words?
No difference between men and women.
Yeah, there's no difference between the proportion of men and women who like what? Proportion of men and women who like pizza. Okay, so our conclusion is even though our samples had 75% of men like pizza and 80% of women like pizza, okay, so even though our samples were like this, okay, this difference of 5% okay, does not convince us that the proportions of men and women who like pizza in the general population is different. Okay. I hope this conclusion can make sense to you guys. Yes?
So for this example, it's very important that you have two different sample sizes.
It's
It sort of depends on that.
it's not that it you don't need two different sample sizes, but you need two samples. Okay, so you're going to have an N1 and you're going to have an N2. Is it okay that you surveyed 200 men and if you surveyed 200 women? That's also okay, but you're going to have two different N's, and that will be the case there.
But if you surveyed 200 men and 200 women,
Uh-huh.
you got 75% of the men and 80% of the women,
You would still go through the same process, okay? Because these are random samples, and you don't know if the 200 men you selected is just an unusual sample where not enough men like pizza, and the 200 women is an unusual sample where too many women like pizza. That comes into play. So in this case, even if you surveyed 200 men and 200 women and 75% of men like pizza and 80% of women like pizza, you still have to go through the process, okay? Is this okay? All right, so we will. So this will end the formal section of class. If you guys want to stick around for more, I'm going to do another example, okay?